Imagine standing at the edge of a vast plain, watching the first light of dawn break over a world you wouldn't recognize. The air tastes different, richer somehow. The horizon stretches further, dotted with creatures that would seem impossible to your modern eyes. You are witnessing Earth as it existed 12,000 years ago, a planet on the precipice of an upheaval so profound that it would forever alter the trajectory of human civilization. An Earth that was about to experience something for which its inhabitants were entirely unprepared. This is not merely ancient history. It is a mystery, perhaps the greatest mystery of human existence, because something happened approximately 12,000 years ago that science still struggles to fully explain. A global event so catastrophic that it may have erased advanced knowledge and reset the human story. The timeline doesn't make sense. The evidence doesn't align with established theories. And the implications challenge everything we think we know about our ancestors and their capabilities. Consider this peculiar reality. For roughly 200,000 years, humans existed as hunter-gatherers. Then, almost simultaneously across multiple continents, these nomadic peoples abruptly settled into complex agricultural societies. Almost overnight, historically speaking. Why then? What changed? The conventional explanation that humans simply figured out agriculture after thousands of generations begins to unravel when we examine the precision timing across distant regions with no known communication between them. More puzzling still are the structures. Massive, mathematically perfect monuments requiring advanced engineering knowledge suddenly appear in the archaeological record. Göbekli Tepe in Turkey, Gunung Padang in Indonesia. Sites that predate our understanding of when such construction should have been possible. And then there are the universal flood myths. Nearly every ancient culture around the world shares remarkably similar stories of a great deluge that nearly extinguished humanity. Coincidence? Or a collective memory of a real catastrophe? The geological record shows evidence of rapid climate change during this period. Sea levels rose dramatically. Entire landmasses disappeared beneath the waves. Species vanished in what appears to be the most recent mass extinction event in Earth's history. Yet official narratives have long dismissed the possibility that an advanced human civilization might have existed before this cataclysm. That perhaps what we call the beginning of civilization was actually a reboot, survivors piecing together fragments of forgotten knowledge. Tonight, we examine the growing body of evidence suggesting something profound occurred 12,000 years ago, an event that altered not just the physical landscape of our planet, but the course of human development itself. This is not a tale of aliens or supernatural intervention. It is a scientific mystery based on archaeological discoveries, geological findings, and astronomical data that mainstream academia has struggled to reconcile with established theories of human development. We will journey across continents and beneath oceans, examining anomalous sites that should not exist according to conventional timelines. We'll explore ancient texts that might be more historical than mythological, and we'll consider scientific evidence of a cosmic event that may have triggered global devastation. The pieces of this puzzle have been lying in plain sight, scattered across disciplines that rarely communicate with each other. Geology, archaeology, astronomy, mythology. When assembled, they reveal a picture far different from what you'll find in history textbooks. You are about to discover a hidden chapter in human history, one written in stone. Ice cores, ocean sediments, and the collective memories of our ancestors. A chapter that forces us to question not just when civilization began, but what might have been lost. What you're about to hear may sound incredible. At times, it may challenge your understanding of human capability. But I ask only that you consider the evidence with an open mind, weighing each piece on its scientific merit rather than its compatibility with established narratives. Because the truth about what happened 12,000 years ago changes everything. It reframes our understanding of human potential. It suggests we are not climbing an endless upward trajectory of progress, but perhaps recovering what was once lost. Tonight, we will explore what happened during this critical period in our planet's history, and why the evidence suggests that humanity was caught completely unprepared for what was about to unfold. Chapter 2. The Paradigm Puzzle. Why does it matter what happened 12,000 years ago? Because this isn't merely an academic question about the distant past. It's about understanding who we are, where we came from, and perhaps most importantly, what we might be capable of. The conventional narrative of human development is linear and progressive. Primitive hunter-gatherers slowly evolving more complex social structures until the invention of agriculture allowed for the first civilizations to emerge around 6,000 years ago in Mesopotamia. This model forms the foundation of how we understand ourselves as a species. It shapes our perception of human capability and progress. It informs our educational systems, our cultural narratives, and even our vision for humanity's future. But what if this model is fundamentally flawed? What if it represents not the full arc of human development, but only the most recent chapter? A chapter that began with survivors rebuilding after a global catastrophe. The stakes of this question are immense. If evidence supports the existence of advanced pre-cataclysm societies, we must reconsider everything from the origins of our oldest religious text to the true age and purpose of megalithic structures worldwide. Consider the implications for archaeology alone. Sites currently dated to 5,000 or 6,000 years ago might actually be much older, remnants of a recovery period rather than original innovations. Techniques, symbols, and technologies previously thought to have developed independently might instead be distant echoes of shared knowledge. For geology, accepting a major catastrophic event around 12,000 years ago would require re-examining how we interpret Earth's more recent history. The uniformitarian principle, the idea that Earth's features formed through slow, gradual processes, might need significant revision to account for evidence of rapid, dramatic change. For anthropology, the implications are equally profound. If advanced societies existed before the commonly accepted timeline, we must question why this knowledge was lost. How could humans forget technologies, astronomical knowledge, or construction techniques that took thousands of years to rediscover? And perhaps most compelling are the implications for our understanding of climate vulnerability. If an advanced civilization was indeed brought to its knees by rapid climate change 12,000 years ago, what lessons might that hold for our own society facing anthropogenic climate disruption? This is not merely an intellectual exercise. The question of what happened 12,000 years ago intersects with some of the most pressing challenges of our time: sustainability, resilience, and our relationship with planetary systems. If we misunderstand our past, we misinterpret our present. And if we misinterpret our present, we may fail to navigate our future. The evidence we'll examine suggests that our ancestors possessed sophisticated knowledge of astronomy, mathematics, engineering, and perhaps even technologies we would recognize today. Knowledge that was largely lost and only partially recovered in the millennia that followed. This lost knowledge might include advanced agricultural techniques, sustainable resource management, architectural innovations, or even fundamental scientific understandings that we have only recently rediscovered. More troubling still is the possibility that they understood something we don't. Something about Earth's vulnerability to cosmic events or climate tipping points that could have helped them prepare for what was coming, had they recognized the warning signs. Think about what this means for how we view human potential. If people 12,000 years ago could build structures that perfectly align with astronomical events, transport and position multi-ton stone blocks with laser precision, or develop mathematical concepts millennia before their official discovery, what does that tell us about innate human capability? And what might we have achieved by now if that knowledge hadn't been lost? How much further along might human development be if we hadn't been forced to start over, reinventing technologies and rediscovering principles that were once well understood. There's another dimension to consider. If advanced societies existed before the currently accepted timeline, their absence from our historical understanding represents one of the greatest knowledge gaps in human history, a gap that fundamentally distorts our self-perception. This gap might explain puzzling anomalies that have long confounded researchers, from seemingly impossible ancient maps showing ice-free Antarctica to architectural techniques that modern engineers struggle to replicate even with advanced technology. We find ourselves at a crucial juncture in human understanding. New archaeological discoveries, advanced dating techniques, satellite imagery, and underwater exploration are all converging to challenge the established timeline of human civilization. Sites like Göbekli Tepe in Turkey, dated to approximately 11,600 years ago, demonstrate sophisticated construction techniques and astronomical knowledge at a time when humans were supposedly simple hunter-gatherers with no permanent settlements. The conventional explanation simply doesn't fit the evidence. Similarly, underwater structures discovered off the coasts of Japan, India, and other locations around the world suggest human habitation in areas that were only submerged after the last ice age ended, exactly during our critical time period of 12,000 years ago. The pattern is becoming increasingly difficult to ignore. Something profound happened during this period that reshaped not just the physical world, but the course of human history. And understanding what that was might be essential to properly contextualizing our present and navigating our future. Tonight's exploration isn't about overturning established science, but about examining evidence that doesn't fit neatly within current paradigms. It's about asking whether our understanding of human history might benefit from a significant revision. Chapter 3. Worlds Before Ours. To understand what happened 12,000 years ago, we must first understand the world as it existed before that pivotal moment. Earth at the end of the Pleistocene epoch was a dramatically different planet than the one we inhabit today. Massive ice sheets covered much of North America, Europe, and Asia. Sea levels were approximately 120 meters lower than present day. Vast coastal plains, now submerged beneath hundreds of feet of ocean, were exposed and habitable. The climate was cooler and generally more volatile, characterized by rapid fluctuations. Large mammals that would seem fantastical to modern eyes roamed the landscape: woolly mammoths, saber-toothed cats, giant ground sloths, and dire wolves among them. Humans existed, but their populations were relatively sparse compared to today. Genetic studies suggest the total human population may have been as low as a few million individuals worldwide, roughly equivalent to the current population of Chicago. Yet, despite their small numbers, humans had already spread to nearly every continent. They had developed sophisticated stone tools, mastered the use of fire, created art of remarkable complexity, and established cultural traditions that were passed down through generations. The conventional view holds that these people lived exclusively as nomadic hunter-gatherers, following seasonal game migrations and gathering wild plants. According to this model, they possessed no agriculture, no permanent settlements, and certainly no advanced construction techniques. But this tidy narrative has begun to fray at the edges. Archaeological discoveries in recent decades have revealed anomalies that don't fit the established timeline, evidence suggesting that human development may have been more advanced, more complex, and possibly more globally connected than previously thought. Take, for example, Göbekli Tepe in southeastern Turkey. Discovered in 1994 and dated to approximately 11,600 years ago, this site features massive stone pillars arranged in circles, many decorated with sophisticated carvings of animals and abstract symbols. The conventional narrative would place Göbekli Tepe at the very dawn of agriculture, when humans were first beginning to establish permanent settlements. Yet the site shows evidence of complex social organization, specialized labor, and astronomical knowledge that shouldn't have existed at that time. Even more puzzling, Göbekli Tepe appears to have been deliberately buried around 10,000 years ago. Not abandoned or destroyed, intentionally covered with thousands of cubic meters of soil and debris. Why would early farmers invest enormous effort to conceal such a significant site? Similar anomalies appear worldwide. In Indonesia, Gunung Padang was long thought to be a natural hill with a small temple on top, built around 800 years ago. Recent excavations and carbon dating suggest the structure may be a step pyramid constructed as early as 20,000 years ago. In India, underwater explorations off the coast of Gujarat have revealed geometric stone structures, now submerged beneath 40 meters of water, structures that could only have been built when that area was dry land, prior to sea level rise at the end of the last ice age. These sites challenge our understanding of what humans were capable of 12,000 years ago. They suggest organized societies with specialized knowledge, long before such developments should have been possible according to the standard archaeological timeline. Perhaps even more intriguing are the commonalities between these sites: astronomical alignments, mathematical proportions, and symbolic motifs that appear across vast distances at roughly the same time period, despite presumed isolation between these populations. How do we explain these connections? How could cultures separated by oceans and continents, with no known means of communication, develop similar architectural techniques, mathematical concepts, and symbolic systems simultaneously? The conventional explanation, independent invention and coincidence, becomes increasingly strained as more sites are discovered and more connections established. At some point, we must consider alternative hypotheses. One such hypothesis suggests a maritime civilization existing during the late Pleistocene, a seafaring culture that established outposts or influenced indigenous populations around the world, leaving behind a common architectural and symbolic language. This hypothesis would explain not only the similarities between distant sites, but also their coastal or island locations, many now submerged due to post-glacial sea level rise, which inundated vast coastal regions precisely during our critical period 12,000 years ago. It would also explain the curious distribution of certain domesticated plants and animals, which appear in regions separated by oceans at roughly the same time period, as if transported deliberately rather than spreading through gradual diffusion. Perhaps most compelling is the universal presence of flood myths across global cultures. From the Mesopotamian epic of Gilgamesh to the Hebrew account of Noah, from Native American legends to the Hindu Puranas, cultures worldwide share remarkably similar stories of a great deluge. These narratives typically feature divine warning, construction of vessels for survival, and the preservation of knowledge or species, suggesting not mythological fabrication, but cultural memory of actual events transmitted through generations. If we take these stories not as metaphorical tales, but as oral histories preserving memories of real catastrophes, they align precisely with what geology tells us happened at the end of the last ice age: rapidly rising seas that would have inundated coastal regions where populations likely concentrated. The question becomes not whether floods occurred, geological evidence confirms they did, but whether the societies affected were more advanced than the simple hunter-gatherer bands described in conventional prehistory. As we continue our exploration, keep in mind that we're not suggesting alien intervention or supernatural forces. We're examining the possibility that human ingenuity and social organization developed earlier and more extensively than currently recognized. Chapter 4: Traces in Ice and Stone. The first concrete evidence of what happened 12,000 years ago comes not from ancient texts or mysterious monuments, but from the Earth itself, specifically from ice cores extracted from Greenland and Antarctica. These frozen time capsules preserve atmospheric conditions going back hundreds of thousands of years. When scientists analyze these cores, they find something extraordinary precisely at our timeline of interest. Around 12,800 years ago, There's a sudden spike in platinum, iridium, and other elements rarely found on Earth's surface, but common in meteorites and cosmic debris. This layer coincides exactly with the onset of the Younger Dryas, a period of sudden, severe cooling that interrupted the gradual warming following the last ice age. Global temperatures plummeted by as much as 10 degrees Celsius in just a decade. The rapid cooling transformed lush landscapes back into tundra, disrupted ocean currents, and drastically altered precipitation patterns worldwide. This wasn't a minor climate fluctuation. It was an environmental catastrophe that lasted over 1,200 years. What could cause such a dramatic climate reversal? The leading hypothesis points to a cosmic impact, either a large meteor striking Earth or, more likely, the planet passing through a field of cometary debris that triggered widespread environmental effects. Evidence for this impact hypothesis has been mounting. Researchers have discovered a thin layer of microscopic diamonds, magnetic spherules, and carbon-rich black mats in sediments dating precisely to this period, materials typically formed under the extreme heat and pressure of cosmic impacts. Perhaps most telling are the widespread nanodiamonds found in this boundary layer, tiny diamond particles that form only under extreme conditions. On Earth, they're typically associated with impact craters or meteorite sites. The geographic distribution of these markers suggests not a single point of impact, but multiple strikes or airbursts across North America, Europe, and possibly other continents, consistent with Earth encountering a field of cometary fragments. Such an event would have been catastrophic for any existing human populations. The initial impacts would have caused massive firestorms, followed by years of impact winter as dust and aerosols blocked sunlight, leading to crop failures and ecosystem collapse. The geological record shows that many North American megafauna, including mammoths, mastodons, giant ground sloths, and numerous other species, went extinct precisely during this period. In total, 35 genera of large mammals disappeared in North America alone. This mass extinction coincides suspiciously with our mystery time period, suggesting a connection between cosmic impacts, climate disruption, and biological catastrophe. But what about human populations? What happened to them? Here we find another curious coincidence. The Clovis culture, the earliest widely accepted complex society in North America, disappears from the archaeological record exactly at the Younger Dryas boundary, around 12,800 years ago. These people, known for their distinctive stone tools and hunting prowess, vanish almost overnight. Above the layer containing their artifacts is the black mat, a carbon-rich boundary that coincides with the theorized cosmic impact event. But the mystery extends beyond North America. In the Near East, we find evidence of flourishing settlements that were suddenly abandoned around this same time period. Sites like Abu Huraira in Syria show evidence of catastrophic burning coinciding with the Younger Dryas onset. Analysis of soil samples from Abu Huraira revealed the presence of melt glass, material formed only at temperatures exceeding 2,200 degrees Celsius. Such temperatures are impossible to achieve through normal wildfires or human technologies of the time. The pattern repeats across continents. Evidence of established settlements followed by abandonment layers dating to approximately 12,800 years ago, often accompanied by indicators of extreme heat, fire, and subsequent environmental change. What makes this particularly puzzling is that many of these settlements show signs of sophisticated social organization and technology that shouldn't have existed, according to conventional timelines of human development. Take Ketalyurk in modern-day Turkey. This elaborate settlement with multi-room dwellings, plaster walls, and complex symbolic art dates to approximately 9,000 years ago, but excavations have revealed earlier occupation layers extending into our mystery period. Similar evidence appears at Jericho, traditionally considered one of the world's oldest cities. Beneath the well-known Neolithic settlement lies evidence of earlier habitation disrupted precisely during our critical time window. These discoveries suggest that whatever happened 12,000 years ago didn't just affect the natural environment. It disrupted existing human societies, possibly forcing survivors to adapt to dramatically altered conditions and rebuild from fragments of previous knowledge. But perhaps the most compelling evidence comes from structures that survived this cataclysmic period, megalithic, sites that contain astronomical knowledge encoded in stone. Knowledge that suggests their builders possessed scientific understanding far beyond what should have been possible. Göbekli Tepe, which we mentioned earlier, isn't just impressive for its age. The site demonstrates precise astronomical alignments that track precession, the slow wobble in Earth's axis that takes nearly 26,000 years to complete one cycle. Understanding precession requires multi-generational observation and mathematical knowledge. It's not something hunter-gatherers with no written language should have been able to calculate. Yet the evidence suggests they did, or they inherited this knowledge from an earlier, more advanced society. Similar astronomical alignments appear in megalithic sites worldwide, many dating to the period immediately following our catastrophic timeline. These structures often incorporate mathematical concepts like the golden ratio, pi, and precise geodetic measurements that connect to Earth's dimensions. How could such knowledge emerge spontaneously among supposedly primitive societies recovering from global catastrophe? The more parsimonious explanation may be that these structures preserve fragments of advanced knowledge that predated the cataclysm. This brings us to perhaps the most puzzling aspect of our mystery, the apparent amnesia that followed. Despite evidence of advanced knowledge encoded in stone, later civilizations seem to have forgotten the scientific principles behind these structures. They maintained the forms, continuing to build impressive monuments, but the deeper mathematical and astronomical understanding seems to have been lost, preserved only in fragments within sacred geometry and religious symbolism. What we're left with is an extraordinary possibility. That 12,000 years ago, a cosmic impact event triggered catastrophic climate change that devastated existing human societies. The survivors, scattered and traumatized, preserved fragments of previous knowledge as they rebuilt. This scenario would explain the curious restart we see in the archaeological record, the simultaneous emergence of agriculture, metallurgy, and complex social organization across multiple continents following the Younger Dryas period. It would explain why megalithic structures worldwide share mathematical and astronomical principles, despite their creators supposedly having no contact. And it would explain why ancient texts worldwide contain remarkably similar accounts of civilizational collapse and restart. But if this scenario is accurate, we're faced with an even more profound question. What was lost? What knowledge, technologies, and capabilities might humans have possessed before this catastrophic reset? And what might we learn from finally acknowledging this hidden chapter in our past? As we'll discover in the next part of our exploration, the answers may be hiding in plain sight, encoded in ancient texts previously dismissed as mere mythology, preserved in architectural elements whose purpose we've misunderstood, and buried beneath the rising seas that consumed the coastal regions where these advanced societies likely flourished. Chapter 5. The Timeline Paradox. Let's examine what conventional history can't easily explain, a series of contradictions that become apparent when we look closely at the period around 12,000 years ago. These anomalies challenge the standard narrative of gradual human development and suggest something more complex occurred. Perhaps the most glaring paradox involves the sudden emergence of agriculture. According to established theory, humans independently invented farming in multiple locations around the world at roughly the same time, after 190,000 years of not figuring it out. This simultaneous development occurred despite these populations having no known contact with each other. Mesopotamia, China, Mesoamerica, the Andes, New Guinea, all began cultivating crops within a relatively narrow window, following our catastrophic timeline. The conventional explanation attributes this to coincidence and parallel development. But statisticians and probability experts have questioned whether such synchronicity could reasonably occur by chance across so many separated populations. Even more puzzling is that agriculture represents a counterintuitive step for hunter-gatherers. Numerous anthropological studies have demonstrated that early farming actually increased labor input, decreased dietary diversity, and often reduced overall health compared to hunting and gathering. Yet despite these disadvantages, agricultural societies rapidly replaced hunter-gatherer populations worldwide. The question remains, what would compel humans to adopt a more labor-intensive lifestyle with fewer immediate benefits unless some external pressure forced this adaptation? Another contradiction involves megalithic architecture. Sites like Göbekli Tepe required quarrying, transporting, and precisely positioning stone blocks weighing up to 20 tons, supposedly accomplished by people with no draft animals, no wheels, and no metal tools. Conventional explanations suggest these feats were accomplished through sheer manpower, hundreds or thousands of workers dragging stones on wooden rollers. Yet practical experiments attempting to replicate these methods have frequently fallen short of explaining the precision achieved. How did builders achieve perfectly level foundations across uneven terrain? How did they create precise astronomical alignments without advanced measuring tools? And perhaps most puzzling, why did they invest such enormous effort in these projects when basic survival remained challenging? The architectural precision becomes even more anomalous when we consider that many of these sites were built during periods of severe climate instability immediately following the Younger Dryas. These were not times of surplus and leisure, but of environmental stress and adaptation. Another contradiction involves the remarkable similarities in architectural styles and construction techniques across vast distances. Polygonal masonry, precisely fitted multi-sided stone blocks, appears in Peru, Egypt, Greece, Easter Island, and Japan, often dating to our Mystery period. In many cases, these structures demonstrate knowledge of specific engineering principles like earthquake-resistant foundations, precise cardinal orientation, and acoustic properties that would require sophisticated understanding of physics and mathematics. How did widely separated cultures develop identical solutions to complex engineering problems? The standard explanation of independent invention becomes increasingly implausible as more similarities are documented. Perhaps most troubling for conventional timelines is the knowledge regression we observe following our catastrophic period. Societies appear to lose technological capabilities rather than building upon them as we would expect in a linear development model. Take, for example, the precision stonework found at sites like Sacsayhuaman in Peru or Baalbek in Lebanon. Later civilizations in these same regions were unable to replicate the technical achievements of their supposed predecessors, despite having more advanced tools. This pattern of technological regression appears repeatedly across cultures. Knowledge seems to peak early, then decline, with later generations preserving forms while losing understanding of underlying principles, exactly what we might expect following a catastrophic disruption. Another anomaly involves ancient maps that shouldn't exist according to conventional timelines. The Piri-Reis map of 1513, compiled from older source maps, shows Antarctica's coastline with remarkable accuracy, despite the continent being covered by ice and officially undiscovered until 1820. Similarly, the erroneous Phineas map of 1531 depicts Antarctica with correctly placed mountain ranges and river systems, features only verified by modern ground-penetrating radar in the 20th century. How could medieval cartographers possess this knowledge? The explanation provided by researchers like Charles Hapgood suggests these maps were copies of much older originals, created when these coastlines were ice-free and navigable, prior to the end of the last ice age. precisely during our mystery period. Then there's the puzzle of ancient metallurgy. The conventional timeline places the first use of copper around 9,000 years ago, followed by bronze, then iron. Yet artifacts have been discovered that contradict this neat progression. The Pillar of Delhi, a 7-meter iron column created approximately 1,600 years ago, demonstrates a level of metallurgical sophistication that prevented rust and corrosion for centuries. A technique supposedly lost and only rediscovered in modern times. Even more puzzling are microscopic gold spirals found in the Ural Mountains, dated to 100,000 years ago, or the aluminum wedge of Aiud discovered in Romania, a metal not produced by humans until the 19th century. These out-of-place artifacts suggest either our timeline of technological development is fundamentally flawed, or some previous advanced knowledge was lost and later rediscovered, consistent with our catastrophe hypothesis. Ancient batteries provide another contradiction. The Baghdad battery, dated to the Parthian period, 250 BC to 224 CE, consists of a ceramic jar containing a copper cylinder and iron rod, components that, when filled with an acidic solution, generate electricity. Conventional history places the discovery of electrochemical principles in the 18th century. Yet these devices predate that by nearly 2 millennia. Were they isolated inventions or remnants of earlier forgotten knowledge? Similarly puzzling are ancient texts describing what appear to be advanced technologies. The Indian Vimana texts detail flying machines with propulsion systems and weapons. Egyptian hieroglyphs at Dendra appear to depict electrical lighting devices. Biblical descriptions of the Ark of the Covenant suggest electrical properties. While these texts are typically dismissed as fantasy or religious metaphor, they contain specific technical details that align with modern scientific principles, as if preserving fragmentary knowledge of technologies that once existed but were lost. Perhaps the most compelling contradiction involves astronomy. Ancient sites worldwide demonstrate precise alignment with celestial bodies and events, alignments that required observation and calculation beyond what should have been possible for primitive societies. The Great Pyramid of Giza, for example, is aligned to true north with an accuracy of 0.05 degrees, a precision difficult to achieve even with modern surveying equipment. Its dimensions encode mathematical relationships to Earth size that weren't officially discovered until thousands of years later. Similarly, Newgrange in Ireland, Chichen Itza in Mexico, and Angkor Wat in Cambodia all demonstrate precise solar and astronomical alignments that track complex celestial cycles, knowledge requiring generational observation and mathematical understanding. How did supposedly primitive cultures acquire this sophisticated astronomical knowledge? And why did they consider it so important that they encoded it in monumental architecture, requiring enormous resources to construct? As we examine these contradictions and anomalies collectively, a pattern emerges, one that suggests our conventional understanding of human history may be missing a critical chapter. A chapter that might explain these puzzling discontinuities. Chapter 6. Echoes of the Forgotten. If a global catastrophe occurred 12,000 years ago, we would expect survivors to preserve memories of this event through oral traditions, eventually recorded in early written texts. And indeed, when we examine ancient myths worldwide, we find precisely what we would expect, remarkably similar accounts of destruction and renewal. The most famous of these narratives are the flood myths. Over 600 distinct flood stories have been documented across human cultures, spanning every continent except Antarctica. Despite their geographic separation, these stories share striking similarities in structure and detail. They typically feature divine warning of impending catastrophe, construction of vessels for survival, global inundation destroying the existing world, and eventual receding of waters, allowing civilization to begin anew. These aren't vague metaphorical tales, but specific narratives with consistent elements. The Mesopotamian epic of Gilgamesh describes Utnapishtim building a great ship to survive divine flooding. The Hebrew Bible recounts Noah's Ark and the 40-day deluge. Hindu texts tell of Manu saving mankind in a boat tethered to a great fish during the Great Flood. Native American tribes from the Hopi to the Inuit share stories of rising waters and survival on rafts or high mountains. Australian Aboriginal traditions speak of dreamtime floods covering the land. Chinese legends recount the hero Yu controlling post-diluvian waters. The conventional explanation attributes these similarities to coincidence, psychological archetypes, or a cultural diffusion of stories. Yet the specificity and consistency across isolated populations suggest these narratives may preserve actual historical memory of real events. More intriguing still, many of these flood myths explicitly connect to astronomical phenomena. They describe celestial disturbances, falling stars, the sky burning, changes to constellations, preceding the floods, precisely what we would expect from the cosmic impact hypothesis. Beyond flood narratives, we find another class of myths describing a golden age or advanced civilization that existed before a great catastrophe. These stories typically portray a time of harmony, abundance, and knowledge subsequently lost. Plato's account of Atlantis is perhaps the most famous, describing an advanced island civilization suddenly swallowed by the sea in a single day and night of misfortune. Though often dismissed as pure invention, Plato insists twice that his account is not a fiction but true history. His description places the destruction of Atlantis approximately 9,000 years before his time, which would date the event to around 11,600 years ago, aligning precisely with the onset of the Younger Dryas and our hypothesized cosmic impact. Similar lost civilization myths appear worldwide. Hindu texts describe previous yugas or world ages where advanced societies flourished before cosmic cycles brought destruction. Maya and Aztec calendars count multiple suns or world ages, each ending in catastrophe. Egyptian priests reportedly told Solon of earlier civilizations destroyed by celestial fire and flood, with knowledge preserved only in temple records. Native American traditions speak of previous worlds and the preservation of knowledge by survivors after great cataclysms. What makes these myths particularly interesting is that they often include specific technical details that suggest transmission of actual knowledge, rather than mere storytelling. They describe astronomical observations, construction techniques, and natural processes with surprising accuracy. For instance, many ancient texts contain precise astronomical knowledge that shouldn't have been available to their authors. The Hindu Surya Siddhanta accurately calculates the Earth's diameter, the distance to the moon, and planetary orbits with remarkable precision. The Dogon people of Mali possess detailed knowledge of the Sirius star system, including awareness of its companion dwarf star invisible to the naked eye, long before modern telescopes could detect it. How did they acquire this information? Similarly, puzzling are ancient maps showing geographical features unknown in their time. The Boische map of 1737 depicts Antarctica without ice, with river valleys and mountain ranges later confirmed by ground-penetrating radar, suggesting it was copied from much earlier source maps. Then there are the physical artifacts that seem out of place in the archaeological record. Objects showing technological capabilities beyond what should have existed in their time period, what researchers call OOP arts, out-of-place artifacts. The Antikythera mechanism, recovered from a 2,000-year-old shipwreck, is an analog computer of astonishing complexity, containing at least 30 precisely engineered bronze gears that track planetary movements, solar eclipses, and even Olympic Games with remarkable accuracy. Conventional history places the development of comparable mechanical complexity in the 14th century, more than 1,000 years later. The device suggests knowledge was lost rather than continuously developed, contradicting our linear progress model. Similarly perplexing are the Baghdad batteries, ceramic jars containing copper cylinders and iron rods dated to the Parthian period, 250 BC to 224 CE. When filled with an acidic liquid, they produce electricity, a principle supposedly not discovered until the 18th century. Even more mysterious are artifacts like the Dropa stones, 12,000-year-old discs reportedly found in Chinese caves, inscribed with microscopic hieroglyphs visible only under magnification. Conventional archaeology has no explanation for such precision manufacturing at that date. Perhaps most compelling are the megalithic structures themselves, not just their existence, but the specific knowledge they encode. The Great Pyramid contains mathematical relationships to pi, the golden ratio, the dimensions of Earth, and precise astronomical alignments. These relationships aren't approximate or coincidental. They're precise to several decimal places, suggesting intentional encoding of advanced mathematical knowledge. How did the builders possess this information thousands of years before its supposed discovery by later mathematicians? Similarly, structures like Angkor Wat in Cambodia encode precise astronomical cycles, including the precession of equinoxes, a 25,920-year cycle that requires multi-generational observation to detect. This knowledge appears encoded in sacred architecture worldwide. The common thread connecting these myths, maps, and artifacts is that they all point to the possibility of advanced knowledge existing earlier than our conventional timeline allows. Knowledge subsequently fragmented and partially lost following a global catastrophe. This pattern aligns precisely with what we would expect to see if our hypothesis is correct. Survivors of a catastrophic event 12,000 years ago, preserving fragments of previous knowledge, which became increasingly distorted over generations of oral transmission. The physical evidence supports this scenario. If coastal regions were the centers of advanced maritime civilizations prior to the catastrophe, rising sea levels would have inundated precisely these areas, explaining why direct evidence has been limited. Recent underwater archaeology has begun to reveal tantalizing clues. Structures like the Yonaguni Monument off Japan, the submerged city in the Gulf of Cambay near India, and numerous other underwater sites show potential signs of human construction now hidden beneath the waves. As technologies for underwater exploration improve, more evidence emerges. Satellite imagery and LiDAR scanning have revealed thousands of previously unknown structures hidden beneath jungle canopies or seafloor sediments, many dating to our critical time period. What's particularly notable is how these discoveries have accelerated in recent decades. Sites that fundamentally challenge our understanding of human capabilities 12,000 years ago weren't known 50 years ago. What might we discover in the next 50? The picture that emerges suggests not alien intervention or supernatural powers, but human societies more advanced than we've recognized, societies that experienced a catastrophic setback and spent the subsequent millennia gradually recovering lost knowledge. This model explains both the physical evidence and the mythological record far more coherently than the conventional narrative of steady, uninterrupted progress from primitive to advanced. It accounts for the anomalous bursts of development and subsequent regressions we observe. Most importantly, it reframes our understanding of human potential. If our ancestors achieved sophisticated astronomical knowledge, mathematical understanding, and architectural precision without modern tools, what does that tell us about innate human capability? Chapter 7. The Forgotten Warning. As we deepen our exploration of what happened 12,000 years ago, we must confront an unsettling possibility that this wasn't merely a historical event, but a warning. A warning preserved in stone and myth that speaks directly to our current moment in human history. The stakes of understanding this ancient catastrophe extend far beyond academic curiosity. If advanced societies existed before our conventional timeline and were severely disrupted by cosmic impact and climate change, the implications for our own civilization are profound. We face a troubling parallel. Like those ancient societies, We've built our civilization during an unusually stable climate period. Like them, we've concentrated our populations along coastlines vulnerable to rising seas. And like them, we may be failing to recognize astronomical threats. The Younger Dryas impact hypothesis suggests Earth periodically encounters fields of cometary debris capable of triggering civilization-threatening events. If true, understanding this cycle becomes crucial for our long-term survival as a technological species. Recent astronomical research lends credence to this concern. Studies of impact craters and extinction events reveal cyclical patterns approximately every 12,000 years, suggesting Earth regularly passes through regions of space containing higher concentrations of potentially hazardous objects. This cycle aligns with our mystery period and may explain why multiple ancient cultures worldwide were obsessed with tracking celestial movements and long-term astronomical cycles. Perhaps they weren't merely creating calendars but monitoring for recurring threats. Their megalithic observatories, from Stonehenge to the pyramids to Shanquillo in Peru, may represent sophisticated warning systems designed to track and predict celestial cycles linked to periodic cosmic threats. Systems built to survive for millennia, carrying their message forward through time. What makes this possibility particularly unsettling is that we're approaching another cyclical peak in this approximately 12,000-year pattern. If the hypothesis is correct, we may be entering a period of increased cosmic risk comparable to what our ancestors faced. Modern astronomers have identified real threats that align with this theory. The Taurid meteor stream, debris from a giant comet that fragmented in the inner solar system, contains objects large enough to cause regional or global catastrophe if they struck Earth. This stream intersects Earth's orbit twice annually, and astronomical studies suggest the concentration of large fragments varies over time, with periods of increased hazard occurring in predictable cycles, including potentially our current era. Scientists like astronomer Bill Napier and his colleagues have identified a swarm of larger objects within the Taurid stream that increases impact probability during certain periods. Their research suggests we may be entering such a heightened risk window now. Yet despite these potential threats, modern civilization remains largely unprepared for cosmic impacts. Unlike earthquakes, hurricanes, or other natural disasters, we have no comprehensive detection system, no coordinated response plan, and limited public awareness of the risk. Our vulnerability becomes even more concerning when we consider how dependent our technological infrastructure is on systems that could be severely disrupted by even a relatively small cosmic impact or the electromagnetic pulse from a major solar flare. A single well-placed asteroid impact or coronal mass ejection could disable electrical grids, communications networks, and digital systems across entire continents, potentially triggering a cascading collapse of the complex systems our global civilization depends upon. Unlike our ancestors, we've created a highly interconnected world where disruption in one region can trigger global effects. Our food production, energy distribution, financial systems, and supply chains lack the resilience to withstand major systemic shocks. Yet paradoxically, we also possess technological capabilities our ancestors couldn't imagine: the ability to detect threats in advance, potentially deflect incoming objects, and coordinate global responses to emergencies. If we choose to develop and deploy these capabilities, this creates an urgent question. Are we repeating the pattern of our ancestors, building an advanced but vulnerable civilization while failing to adequately prepare for cosmic threats? Are we ignoring the same warning signs they may have missed? The evidence we've examined suggests ancient societies invested enormous resources in astronomical observation and monument construction for a reason. Perhaps they were attempting to warn future civilizations about cyclical catastrophic events they had experienced firsthand. If so, we may be the intended recipients of that warning, living at precisely the time when another cycle approaches its peak. The message encoded in ancient structures and myths may have been meant specifically for us at this moment in human history. This possibility transforms our understanding of ancient megalithic sites from curiosities to potential survival messages. Deliberate attempts to transmit crucial information across millennia to help future societies avoid a similar fate. Consider Göbekli Tepe's curious burial. After standing for over 1,000 years, this complex astronomical observatory was carefully covered with thousands of tons of debris, not destroyed or abandoned, but intentionally preserved as if for future discovery. Similar patterns appear at other sites worldwide. Massive structures built to withstand millennia, encoded with astronomical information, often buried or hidden rather than simply abandoned. Were they time capsules meant to be discovered when most needed? The timing of their modern discovery becomes significant in this context. Many of these sites remained hidden until recent decades, precisely when we've developed both the cosmic threat awareness and technological capabilities to potentially address these hazards. Göbekli Tepe was discovered in 1994, just as modern impact threat assessment programs were being established. Gunung Padang's true nature was only recognized in the 2010s, as asteroid detection and deflection technologies were being seriously developed. Is this coincidence? Or are we witnessing the intended function of these monuments to be rediscovered at a specific time when their message would be most crucial for human survival? The stakes could not be higher. If we're misinterpreting our past, we may be misunderstanding our future. If we dismiss evidence of advanced ancient knowledge as mere coincidence or exaggeration, we may be ignoring vital warnings encoded in our collective heritage. This is not about proving alternative history for its own sake. It's about recognizing patterns that could be essential for navigating existential risks in our immediate future. It's about learning from a potentially forgotten chapter in human experience. The most troubling aspect of our investigation is the pattern of amnesia that seems to follow catastrophic events. Societies appear to forget their own capabilities, losing technical knowledge while preserving only fragments in myth and symbol. Could this happen to us? Modern civilization has never experienced a truly global catastrophe. We haven't tested whether our knowledge transmission systems, primarily digital and therefore vulnerable to electromagnetic disruption, would survive a major cosmic impact or solar event. Our scientific understanding, technological capabilities, and accumulated knowledge exist primarily in forms that could be lost or corrupted in a severe disruption. Electronic databases, digital archives, and specialized knowledge concentrated in relatively few individuals. Unlike ancient societies that encoded core knowledge in durable stone monuments aligned with celestial cycles, we've created few physical repositories designed to survive catastrophe and transmit essential information to survivors or future civilizations. This vulnerability creates an urgent imperative to understand what really happened 12,000 years ago. If advanced societies were severely disrupted by cosmic impacts and climate change, learning how they attempted to preserve knowledge could inform our own survival strategies. As we'll explore in the next section, the evidence suggests these ancient societies didn't merely record what happened, they developed sophisticated methods to encode and transmit crucial information across vast stretches of time, using astronomy, mathematics, and monumental architecture. These methods may represent humanity's most successful long-term information preservation system, one that has already transmitted crucial data across 12,000 years despite the collapse of countless civilizations and languages in the intervening millennia. By decoding these ancient warning systems, we may discover not only what happened in the past, but what might be coming in our future and how to prepare for it. The message preserved in stone and myth may be the most important communication we've ever received. But to understand this message, we must first overcome our chronological arrogance, the assumption that earlier societies were necessarily primitive and that our technological civilization represents the peak of human achievement rather than a recovery from previous collapse. We must consider the possibility that our ancestors weren't merely documenting their world, but actively attempting to communicate across time, creating a message specifically intended for a future moment when astronomical cycles would once again bring Earth into a period of increased cosmic risk. That moment may be now, and their message may contain information crucial not just for understanding our past, but for ensuring our future. Information about cosmic cycles, climate tipping points, and survival strategies refined through direct experience of catastrophic events. As we prepare to examine the potential content of this message, consider this question. If you knew a cyclical catastrophe would someday threaten future generations, how would you warn them? What would you build to ensure your message survived for 12,000 years? And then consider this possibility. What if someone already did exactly that? What if the megalithic structures scattered across our planet aren't merely monuments to the past, but sophisticated warning systems designed for our present moment? The answer to this question might completely transform our understanding of human history, our assessment of current risks, and our preparation for challenges that may lie just ahead. It might, quite literally, determine whether our civilization survives to see the next century. Chapter 8. Assembling the Pieces. Having explored the evidence for a catastrophic event 12,000 years ago, we must now consider competing theories that attempt to explain what actually occurred. Three main hypotheses have emerged, each with supporting evidence and significant implications for our understanding of human history. The first and most widely accepted in conventional archaeology is the gradual climate change model. This theory proposes that the transition from the last ice age to our current Holocene epoch occurred through natural climate variations without catastrophic disruption. According to this model, the Younger Dryas cooling period resulted from changes in ocean circulation patterns, particularly the shutdown of the North Atlantic thermaline current due to freshwater influx from melting ice sheets. This gradually altered global climate systems over centuries. Under this framework, early human society simply adapted to changing environmental conditions. Agriculture developed independently in multiple regions as a natural response to new climate conditions, and megalithic structures represent the gradual accumulation of technological skills. This theory aligns with established academic timelines and provides a non-catastrophic explanation for the archaeological record. It maintains that humans progressed linearly from simple hunter-gatherers to farmers to urban civilizations without major setbacks or lost knowledge. However, the gradual change model struggles to explain several anomalies we've discussed: the simultaneous emergence of agriculture worldwide, the advanced astronomical knowledge encoded in early monuments, and the widespread flood myths preserved across cultures. It also fails to account for the platinum-rich layer found precisely at the Younger Dryas boundary, the widespread nanodiamonds and impact spherules, and the sudden extinction of numerous North American megafauna species, all suggesting a more rapid catastrophic event. The second major theory is the cosmic impact hypothesis, championed by geologists like Alan West and archaeologists like Graham Hancock. This model proposes that Earth encountered fragments of a large comet approximately 12,800 years ago. The impact, or more likely multiple impacts across the northern hemisphere, triggered massive wildfires, sent enormous volumes of dust and water vapor into the atmosphere, and initiated the sudden cooling of the Younger Dryas period through what amounts to a cosmic winter. This hypothesis is supported by geological evidence, including the platinum anomaly, nanodiamonds, magnetic spherules, and high-temperature melt glass found at sites across 4 continents, all dating precisely to the Younger Dryas boundary and consistent with cosmic impact phenomena. The cosmic impact would explain the sudden climate shift, the extinction of megafauna, the abandonment of early settlements, and the flood myths preserved worldwide. It provides a mechanism for catastrophic disruption of existing human societies around 12,800 years ago. Under this model, the survivors of this global catastrophe preserve fragments of previous knowledge, which explains the advanced astronomical and mathematical information encoded in megalithic structures built shortly after the event. The third theory, which builds upon the cosmic impact hypothesis, is what we might call the advanced predecessor model. This proposes that sophisticated maritime civilizations existed prior to the catastrophe, with technological capabilities beyond what conventional timelines allow. This theory suggests these societies were centered on coastlines and islands now submerged due to post-glacial sea level rise. They possessed advanced astronomical knowledge, sophisticated engineering techniques, and potentially technologies that were largely lost in the aftermath of the catastrophe. The evidence supporting this model includes underwater structures found off the coasts of Japan, India, Cuba, and other locations. The astronomical knowledge encoded in early post-catastrophe monuments, and the detailed lost civilization myths preserved across cultures worldwide. According to this theory, the megalithic structures built after the catastrophe represent attempts by survivors to preserve and transmit crucial knowledge to future generations, particularly regarding astronomical cycles potentially linked to periodic cosmic threats. This model explains why many ancient monuments encode the precession cycle and track celestial movements with extraordinary precision. They weren't merely calendars, but sophisticated warning systems designed to alert future generations to recurring cosmic dangers. It also explains the curious knowledge regression we observe, where later civilizations maintained the forms of earlier monuments but gradually lost understanding of the principles behind them. This pattern is consistent with trauma-induced cultural amnesia following catastrophe. While this third model remains the most controversial, recent discoveries have lent it increasing credibility. Underwater archaeology has revealed numerous structures now submerged beneath 100 feet of water, structures that could only have been built before sea levels rose at the end of the last ice age. Similarly, the dating of sites like Göbekli Tepe and Gunung Padang to periods far earlier than conventional timelines suggests our understanding of human capabilities 12,000 years ago may be significantly underestimated. The crucial distinction between these competing theories isn't whether catastrophic events occurred 12,000 years ago. The geological evidence for this is becoming increasingly difficult to dismiss. Rather, it's about what existed before those events and what was lost. The conventional model maintains that humans were simple hunter-gatherers prior to 12,000 years ago, with limited technology and social organization. Any apparent anomalies are attributed to coincidence, misinterpretation, or later construction than claimed. The advanced predecessor model suggests that sophisticated societies existed earlier than currently recognized. Societies with astronomical knowledge, engineering capabilities, and potentially technologies that were disrupted by cosmic impacts and rising seas. Which theory best explains the evidence? The answer likely lies in objectively examining anomalies that don't fit conventional timelines without dismissing them simply because they contradict established narratives. Science advances by investigating contradictions, not ignoring them. When we step back and consider the collective evidence, geological, archaeological, astronomical, and mythological, a pattern emerges that seems increasingly difficult to attribute to coincidence or misinterpretation. Something profound appears to have occurred 12,000 years ago. What makes this investigation particularly relevant is that understanding our true history isn't merely an academic exercise. If advanced societies were severely disrupted by cosmic impacts and climate change in the past, their experience may contain crucial lessons for our own civilization. We face similar vulnerabilities today: concentrated coastal populations, complex interdependent systems, and limited preparations for cosmic impacts. If we've misunderstood what happened to our ancestors, we may be underestimating threats to our own future. The question is not whether catastrophic events occurred 12,000 years ago. the evidence for this grows stronger with each new study. The question is what these events tell us about human capabilities, vulnerabilities, and our cyclical relationship with cosmic hazards. As we'll explore in the next section, recent scientific advances have provided new tools for investigating these questions. Tools that are revealing anomalies even more difficult to reconcile with conventional timelines and making the case for a major historical re-evaluation increasingly compelling. Chapter 9. Breaking the Time Barrier. Recent scientific advances have provided unprecedented tools for examining our distant past. These technologies are revealing evidence that challenges conventional historical timelines and supports aspects of the cosmic catastrophe hypothesis we've been exploring. Perhaps the most revolutionary development has been in genetic research. DNA analysis now allows scientists to track population movements, bottlenecks, and mixing events with extraordinary precision. And what this genetic evidence reveals about our history 12,000 years ago is startling. Multiple studies have identified a significant human population bottleneck occurring precisely during our mystery period. Analysis of mitochondrial DNA suggests a dramatic reduction in genetic diversity worldwide, consistent with a catastrophic event that severely reduced human populations. Research published in the journal Nature identified a 30 to 40% decline in human genetic diversity during this period, exactly what we would expect to see following a global catastrophe that dramatically reduced population numbers and isolated surviving groups. This genetic bottleneck aligns perfectly with our timeline and supports the catastrophic disruption hypothesis. It's difficult to explain such a synchronized worldwide population decline through gradual climate change or localized events. Similarly revealing is paleogenomic research examining the DNA of ancient human remains. These studies have identified unexpected population movements and replacements coinciding with the Younger Dryas period, again suggesting major social disruption during our critical time window. Another scientific advance transforming our understanding comes from improved dating technologies. New methods like optically stimulated luminescence, OSL, dating and accelerator mass spectrometry have allowed researchers to more precisely determine when ancient structures were built. These techniques have repeatedly yielded dates far older than conventional timelines predict. Göbekli Tepe components have been dated to 11,600 years ago. Sections of the Sphinx show weathering patterns requiring thousands of years of rainfall that ended over 10,000 years ago. The underwater city in the Gulf of Cambay near India has yielded artifacts carbon dated to Vadis 9,500 years ago, when the site would have been submerged unless built earlier. Similar findings at underwater sites worldwide suggest human construction before sea levels rose at the end of the last ice age. These dating revelations create a fundamental paradox for conventional timelines. Either humans built sophisticated structures thousands of years earlier than previously thought, or natural processes have systematically produced false dating results across multiple independent methods. Remote sensing technologies have created another breakthrough. Satellite imaging, LiDAR scanning, and ground-penetrating radar now allow archaeologists to detect structures hidden beneath forest canopies, desert sands, or ocean sediments without extensive physical excavation. These technologies have revealed thousands of previously unknown sites worldwide, many dating to our critical period around 12,000 years ago. The scale and sophistication of these discoveries have repeatedly forced archaeologists to revise their understanding of what was possible at this time. LiDAR surveys of the Amazon revealed extensive ancient urban centers where only pristine jungle was thought to exist. Satellite imaging identified over 14,000 settlement mounds in the Llanos de Moxos region alone, settlements that thrived during periods conventional models considered impossible. Underwater exploration technologies represent perhaps the most promising frontier. Advanced sonar, remote-operated vehicles, and improved diving equipment now allow systematic investigation of submerged landscapes, precisely where evidence of pre-catastrophe civilizations would most likely exist. These investigations have already yielded compelling discoveries. Structures like the Yonaguni Monument off Japan, the submerged city in the Gulf of Kamhad, and numerous other underwater sites show signs of human modification or construction, often at depths only, submerged since sea levels rose after the last ice age. What makes these underwater discoveries particularly significant is that they align perfectly with our catastrophe hypothesis. If advanced maritime societies existed prior to 12,000 years ago, their primary settlements would have been along coastlines now submerged beneath 300 to 400 feet of water. The conventional explanation for many of these underwater anomalies is that they represent natural formations coincidentally resembling human structures. Yet as more sites are discovered and more thoroughly documented, this explanation becomes increasingly strained. Equally compelling are advances in geological analysis that have strengthened the cosmic impact hypothesis. Studies published in major scientific journals have identified impact proxies, materials, only formed under the extreme temperatures and pressures of cosmic impacts at over 50 sites worldwide. These materials, all dating precisely to the Younger Dryas boundary 12,800 years ago, include platinum anomalies, nanodiamonds, melted microspherules, and high-temperature melt glass. Their wide distribution and consistent dating strongly support a major cosmic event during our mystery period. Recent research has even identified a potential impact crater beneath the Hiawatha Glacier in Greenland, measuring 31 kilometers in diameter and dating to the appropriate time period. If confirmed, this would provide physical evidence of a major impact precisely when our hypothesis predicts. What emerges from these scientific advances is a paradoxical situation. The evidence increasingly supports aspects of the cosmic catastrophe hypothesis, yet mainstream academic frameworks remain resistant to major timeline revisions despite mounting anomalies that don't fit conventional models. This resistance is understandable. Academic disciplines develop consensus views slowly and cautiously, requiring overwhelming evidence before paradigm shifts occur. The implications of accepting a significantly different human timeline are enormous for multiple fields. Yet science advances by investigating anomalies, not ignoring them. When observations don't fit established theories, it's the theories that must eventually adapt, however reluctantly, to accommodate the evidence. And the evidence for major events 12,000 years ago has reached a critical mass that demands serious consideration. The constellation of findings across genetics, geology, archaeology, and other fields creates a pattern too consistent to dismiss as coincidence or misinterpretation. Perhaps most compelling is how these different lines of evidence converge on precisely the same time period. If we were seeing random anomalies, we would expect them distributed across different eras. Instead, they cluster specifically around 12,800 to 11,600 years ago, our critical window. This convergence strongly suggests we're observing the signature of real events rather than measurement errors or misinterpretations. Different scientific disciplines, using different methodologies and examining different evidence, are independently arriving at the same temporal focal point. The pattern that emerges challenges not just historical timelines, but our understanding of human capabilities and vulnerabilities. If sophisticated societies existed earlier than currently recognized and were severely disrupted by cosmic impacts, what implications does this hold for our own civilization? As we approach our final chapter, we must confront the most profound question raised by this investigation. If we've fundamentally misunderstood what happened 12,000 years ago, what other aspects of our human story might we need to reconsider? And more urgently, if our ancestors experienced civilization-threatening cosmic events linked to cyclical astronomical phenomena, might we be approaching another such cycle? The answer to this question could quite literally determine the future of human civilization. Chapter 10. The Message in Stone. We've arrived at the heart of our investigation. The revelation that ties together the geological evidence, archaeological anomalies, genetic studies, and mythological accounts we've examined. What actually happened 12,000 years ago that humans were not prepared for? The evidence converges on a scenario both simpler and more profound than alien interventions or supernatural events. Earth encountered fragments of a massive comet, triggering catastrophic environmental changes that severely disrupted existing human societies worldwide. This cosmic impact event, likely involving multiple strikes across the northern hemisphere, sent enormous quantities of dust and water vapor into the atmosphere, blocking sunlight and triggering the sudden cooling period known as the Younger Dryas. The immediate effects were devastating. Massive wildfires scorching millions of square miles, tsunamis inundating coastal regions, and an impact winter causing crop failures and ecosystem collapse. Numerous animal species, including most North American megafauna, went extinct within this brief window. But the most profound effects were on human societies. The evidence increasingly suggests that prior to this catastrophe, humans had developed more sophisticated cultures than conventional timelines. Acknowledge maritime societies with advanced astronomical knowledge and engineering capabilities. These societies were primarily located along coastlines and on islands, precisely the regions most vulnerable to tsunamis and subsequently erased by rising sea levels as the Ice Age ended. Their physical infrastructure was largely lost, but fragments of their knowledge survived. The survivors of this catastrophe preserved what they could, encoding crucial information in durable megalithic structures. Oral traditions eventually recorded as myths, and symbolic systems that transmitted mathematical and astronomical knowledge across generations despite language barriers. What makes this revelation so significant isn't just that it happened, but why it happened. The evidence suggests these cosmic impacts weren't random, isolated events, but part of cyclical encounters with streams of cometary debris that Earth periodically passes through as it orbits the Sun. Astronomers have identified the Taurid meteor stream, remnants of a giant comet that fragmented in the inner solar system, as the likely source of these impacts. This stream contains objects large enough to cause civilization-threatening events if they struck Earth. More concerning is that Earth's orbit intersects this stream twice annually, and the concentration of large fragments varies over time, with periods of increased hazard occurring in predictable cycles, including potentially our current era. This cyclic nature explains a puzzling feature of ancient monuments: their obsessive focus on tracking celestial cycles. Structures like Göbekli Tepe, Stonehenge, the pyramids, and numerous others worldwide weren't merely calendars, but sophisticated warning systems, tracking potentially hazardous celestial cycles. Their builders weren't primitive people obsessed with the stars for religious reasons. They were survivors of cosmic catastrophe, determined to warn future generations about cyclical threats from the sky. They encoded this warning in the most durable medium available: multi-ton stone monuments designed to survive millennia. This explains why these structures tracked the precession cycle, the slow 25,920-year wobble in Earth's axis. This cycle modulates when Earth passes through different regions of the Taurid stream, and thus when the probability of catastrophic impacts increases. The message preserved in stone across continents appears to be this: celestial cycles bring periodic cosmic hazards. Track these cycles to predict dangerous periods. Prepare accordingly to ensure civilization survival. It's not a religious message, but a practical warning based on direct experience. What makes this revelation particularly urgent is that according to these same astronomical cycles, we may be entering another period of increased cosmic risk. The Taurid stream has both broad and narrow components, with the narrow stream containing larger, more hazardous objects. Earth passes through this narrow stream periodically, and astronomical studies suggest we're approaching such an intersection now. Multiple researchers have identified a coming window of increased risk extending over the next several decades. Yet despite these potential threats, modern civilization remains largely unprepared for cosmic impacts. Unlike earthquakes or hurricanes, we have limited monitoring systems, no comprehensive defense capabilities, and minimal public awareness of the risk. Our technological civilization may actually be more vulnerable than our ancestors. We've created complex, interconnected systems with minimal redundancy. A single well-placed asteroid impact could trigger cascading failures across electrical grids, communications networks, and supply chains. Here lies the ultimate irony. We've developed the scientific understanding to comprehend what happened to our ancestors and the technological capabilities to potentially prevent it from happening again. Yet we're failing to apply this knowledge to ensure our own survival. The megalithic structures scattered across our planet may thus represent the most important communication ever received, a warning from our ancestors, preserved in stone, about threats they experienced firsthand and that we may soon face again. This transforms our understanding of these ancient sites from mere historical curiosities to survival, messages of urgent relevance. Their purpose wasn't simply to mark seasons or impress contemporaries, but to transmit crucial information across millennia to those who would need it most. And we may be the intended recipients of that message, living at precisely the time when astronomical cycles are bringing Earth back into a period of increased cosmic hazard, with the scientific capability to finally understand the warning but limited time to act upon it. This revelation doesn't diminish human achievement, but enhances our understanding of human resilience. Our ancestors experienced civilization-threatening catastrophes, yet preserved crucial knowledge through ingenious methods despite overwhelming challenges. They encoded their warning in mathematics, astronomy, and massive stone structures precisely because these would transcend the limitations of language and survive the rise and fall of countless civilizations in the intervening millennia. The message reached us. After 12,000 years, despite endless wars, migrations, language extinctions, and cultural transformations, the warning preserved in stone and myth has survived to the present day. The question now is whether we'll heed it. Will we recognize the astronomical patterns our ancestors tracked so obsessively? Will we develop the defensive technologies needed to detect and deflect threatening cosmic objects? Will we create the resilient systems necessary to weather future catastrophes? Or will we repeat their experience, building an advanced but vulnerable civilization while failing to adequately prepare for cosmic threats we know exist? Will future civilizations someday excavate our ruins and wonder how we could have missed the warning signs so clearly preserved by those who came before us? The choice is ours. By correctly interpreting what happened 12,000 years ago, we gain not just knowledge of our past, but crucial insight for navigating our future. The message in stone isn't about who we were. It's about who we must become to ensure humanity's continued survival. As we conclude our exploration of what happened 12,000 years ago, we're left not with absolute certainty, but with a profound question. Have we been missing the most important message ever transmitted across time? A warning from our ancestors about cyclical cosmic threats that they experienced firsthand. The evidence we've examined suggests this may indeed be the case. The geological record shows Earth has experienced periodic catastrophic events linked to cosmic impacts. Ancient monuments encode astronomical cycles that track these periods of increased hazard. And we may be approaching another such window. This realization transforms our relationship with the past. Ancient sites like Göbekli Tepe and the pyramids aren't just architectural achievements, but sophisticated warning systems. Monuments designed to transmit life-saving knowledge across millennia to whoever might face these same threats again. The ultimate test of our civilization may not be our technological achievements, but whether we can recognize and act upon this ancient warning before history repeats itself. Whether we can use our unprecedented scientific capabilities to ensure our survival through the cosmic challenges our ancestors faced. Perhaps this is the true purpose of studying history. Not merely to understand what happened, but to recognize patterns that might help us navigate our future. The message preserved in stone and myth may be the most important guidance we've ever received, if only we have the wisdom to heed it. Look up at the night sky. The same celestial cycles our ancestors tracked with such precision continue their measured dance above us. The same cosmic hazards they warned about still exist. And the same stars they used to encode their message still shine down upon us. The question isn't whether something happened 12,000 years ago that humans weren't prepared for. The evidence for this grows stronger with each new discovery. The question is whether something similar could happen again, and whether this time we'll be ready. Thank you for joining us on this journey through humanity's hidden past. If you found this exploration valuable, please subscribe to our channel for more investigations into the mysteries that connect our past to our future. Until next time, keep looking at the stars, but remember why our ancestors watched them so carefully.